Welcome back to the Docker for Developer series. So far, we have understood what Docker is, how Docker architecture works, and the difference between Docker images and containers. But today, we are finally going to get our hands dirty. We are going to install Docker, verify that everything is working, run our very first container, and then run an actual web server inside Docker. And there is something important about today's video. I'm not just going to show you the happy path. I'll also show you some of the most common errors beginners face, why they happen, and exactly how to think about fixing them. Because learning Docker isn't just about memorizing commands. You need to understand what Docker is doing behind the command. So let's start. Here is our journey for today. First, we will install Docker. Then we will check whether Docker is actually running. Next, we will use Docker's Hello World image. After that, we will run something more interesting, an Nginx server. We will connect the container to our browser and understand how port mapping works. Finally, we will clean everything up and look at common errors. And I strongly recommend following along on your own machine while watching this video. Before installing Docker, let's clear up an important misconception. Docker is not exactly the same thing as Docker Desktop. Docker Engine is the core technology responsible for building and running containers. Docker Desktop is a convenient application that packages Docker components together and provides a graphical interface and command line access, especially for Windows and Mac OS users. On Linux, Docker Engine can run directly on the host operating system. So don't think Docker Desktop equals Docker. Instead, think Docker Engine is the core container engine, while Docker Desktop is a convenient development environment for Docker, particularly on Windows and Mac OS. For Windows and Mac OS, the easiest starting point is Docker Desktop. Download the installer from Docker's official website and install it according to your operating system. After installation, start Docker Desktop. This part is extremely important. Installing Docker doesn't necessarily mean the Docker engine is currently available. Docker needs to be running before your commands can communicate with the Docker daemon. So after installation, don't immediately start running commands. First, make sure Docker has started successfully. Let's open our terminal. Our first command is docker version. This checks whether the Docker command line client is installed and available in our path. You should see a Docker version printed. But there is an important distinction here. If you get a version number that proves that the Docker CLI is installed, it does not necessarily prove that the Docker daemon is running. That's why we need another check. Now let's run docker info. This command asks the Docker daemon for information. If Docker is working properly, you will see information about the Docker environment. This is a useful troubleshooting command. And here is one of the first common errors beginners see. You may get something like cannot connect to Docker daemon. Don't panic. That doesn't mean Docker is broken. It usually means that Docker client is available, but the Docker daemon isn't running or isn't reachable. So the first thing you should check is whether Docker Desktop or the Docker service is actually running. This is our first important misconception. A lot of beginners run Docker version. They see a version number and think Docker is completely ready. Not necessarily. That command mainly confirms that CLI is installed. If you want to verify that Docker can actually communicate with its engine, commands such as docker info are much more useful. This small distinction will save you a lot of debugging time. Now we are ready for our first container. Run docker run hello-world. This is a very important command, so let's not just execute it and move on. Let's understand what Docker has to do. When we run docker run hello-world, Docker first checks whether the hello world image exists locally. If it doesn't exist, Docker needs to get it from a registry. Usually that means Docker Hub. if we are using the default configuration. Docker downloads the image, then Docker creates a container from that image. Then it starts the container. The program inside the container runs. And finally, we see the hello world output in our terminal. So one short command actually represents several operations. Here is another very common misconception. People think Docker run means start an existing container. That's not the best way to think about it. Conceptually, Docker run is used to create and start a new container from an image. This distinction becomes very important later when we learn Docker start, because Docker start is used to start an existing stopped container. So remember, run, create and start a new container. Start is start an existing container. Now think about our previous video where we had distinctions between image and a container. What did Docker download here? It downloaded an image. Then Docker created a container from that image. The image is the reusable blueprint. The container is the actual instance. This is exactly the image versus container relationship we discussed earlier. And this is why understanding the fundamentals before running commands is so useful. Now, let's see whether our container is running. We use Docker PS. This lists currently running containers. But you may notice something surprising. You might not see our hello world container here. Why? Because the program inside that container completed its job and exited. This is an extremely important Docker concept. If you want to see stopped containers as well, use docker ps-a. Now you'll probably see the hello world container. Its status will indicate that it has exited. This does not mean something went wrong. The container's job was simply to print a message and finish. Once the main process finishes, the container stops. And that's one of the biggest concepts beginners need to understand. Many beginners see exited and immediately think my Docker container crashed. Not necessarily. Container generally lives as long as its main process is running. If the main process finishes successfully, the container exits. For Hello World, that's exactly what we expect. The program prints its message and finishes. So, an exited container can be completely normal. Now, let's do something more interesting. We are going to run Nginx inside a container. Nginx is a popular web server. Run docker run Nginx. But be careful. If you run this exactly as shown, the terminal may remain attached to the container's output. That's because the container is running a web server in the foreground. Let's understand what we actually want. We want Nginx running in the background so that we can continue using our same terminal. Now we will add -d to our command. Our command now becomes docker run -d nginx. The -d option means detached mode. Docker starts the container in the background and returns control of our terminal. You will get a long string printed. That is the container ID. And this is an important habit. Don't memorize options blindly. When you see -d, think run this container detached from my terminal. Now we have Nginx running. Naturally, you might try opening localhost in your browser. But don't be surprised if it doesn't work. Why? Because the Nginx process is running inside the container. The container has its own network environment. Our host machine's port isn't automatically connected to the container's port. This brings us to one of the most important Docker concepts, port mapping. Nginx normally listens on port 80 inside the container, but we want to access it through our computer. So we map a port on our host machine to the container's port. For example, host port 8080 to container port 80. The relationship becomes localhost colon 8080 to container colon 80. This means when someone accesses port 8080 on my computer, forward that traffic to port 80 inside the container. Now let's run docker run -d -p 8080 colon 80 nginx. This command has three important parts. First, docker run, create and start a container. -d, run it in detached mode. Now -p 8080 colon 80, map host port 8080 to container port 80. So if in my browser, in my host machine, anyone sends a request for 8080, it is forwarded to 80 port of my container. And finally, Nginx is the image we are using. Now open your browser and visit localhost colon 8080. You should see the Nginx welcome page. This is one of the most common Docker mistakes. Many beginners reverse these two numbers. When we write -p 8080 colon 80, the first number is the host port. The second number is the container port. So 8080 colon 80 means host is 8080 maps to container port 80. You can remember it as outside colon inside. Host outside the container and the container inside after colon. Now let's talk about errors. Suppose you run docker run -d -p 8080 colon 80 nginx and docker says port is already allocated. What does that mean? It means something else is already using port 8080 on your machine. It could be another container, it could be a Java application, or it could be another local service. Docker can't bind two different processes to the same host port in the same way. So we have two choices: stop whatever is using port 8080 or choose another host port. For example, we can use port 8081. Docker run -d -p 8081 colon 80 nginx. Notice something important. We changed the host port. We did not change Nginx internal port. Nginx is still listening on port 80 inside the container. Now we access localhost 8081. This distinction between host port and container port is incredibly important. Here is another error you will eventually encounter. Suppose we give our container a name, docker run -name nginx-app nginx. Later we run the same command again. Docker may say that the container name is already in use. Why? Because container names must be unique. The old container may be stopped, but it still exists. You can either remove the old container or use another name. Another common situation is you type docker run my-app and docker says it can't find the image. This usually means docker doesn't have an image with that name available locally or in a registry it can access. With public images, Docker may attempt to pull the image. But if you type the wrong image name or tag, the pull can fail. So when you see an image related error, check image name, tag, registry, whether the image exists locally. This is another classic beginner problem. When you run your application and immediately see that the container has exited, don't immediately delete everything and start again. First ask what was the container's main process. Remember what we learned with Hello World. When the main process finishes, the container stops. For an application container, an immediate exit could mean the application itself failed to start. That's when we need logs. If a container stops unexpectedly, one of the first commands I recommend is docker logs, followed by the container name or ID. For example, docker logs my-app. This shows the output generated by the container's main process. If your Spring Boot application failed because of a database connection, configuration problem, missing environmental variables, or another startup issue, logs are often the first place you should look. Another very simple but common error is Docker command not found. This usually means your terminal can't find the Docker CLI. Possible reasons include Docker is installed, Docker is not available in your path, or your terminal needs to be restarted after installation. So don't start debugging containers when the Docker command itself isn't available. Always troubleshoot from the bottom up. This is probably the most valuable slide in today's video. When Docker doesn't work, don't randomly try commands from Stack Overflow. Follow a logical debugging process. First, is Docker installed? Second, is the Docker engine running? Third, does the image exist? Fourth, did the container actually start? Fifth, is the application running inside it? And sixth, are the ports mapped correctly? And finally, check the logs. This mindset is much more valuable than memorizing 50 Docker commands. Now let's clean up. First, use Docker PS to see containers running. Then stop the container, Docker stop container name. Once it's stopped, you can remove it with the command docker rm container name. Remember, stop and remove are different operations. Stopping a container doesn't delete it. Removing a container deletes that container instance. The image can still remain available. Here is another misconception. If you delete a container, you have not necessarily deleted the image. The image is reusable. You can create another container from the same image. This is one of the reasons Docker is so powerful. The image represents the packaged application environment. Containers are disposable instances created from that image. Let's look at everything we did today. So we installed Docker, verified the CLI, verified communication with the Docker engine, then ran Hello World, inspected the container, ran Nginx, mapped a host port to a container port, opened the application through our browser, learned how to troubleshoot common errors, and finally cleaned up our containers. This is already enough practical knowledge to start experimenting with Docker on your own. If you remember nothing else from this video, remember these 7 things. Docker CLI and Docker engine are not the same thing. Docker run isn't the same as Docker start. An image is not a container. An exited container isn't automatically an error. Host ports and container ports are different. Deleting a container doesn't necessarily delete its image. And when something goes wrong, check the logs. These simple concepts will prevent a huge number of beginner mistakes. These are excellent interview questions. And notice something, we are not learning Docker only to pass interviews. If you actually understand today's concepts, the interview answers become natural. For example, if an interviewer asks, what does -p 8080 colon 80 mean? You should immediately be able to explain that port 8080 on the host is mapped to port 80 inside the container. That's understanding. Now you have crossed an important milestone. You haven't just learned what Docker is, you have actually installed it, started a container, exposed a web server, accessed it through your browser, and debugged common problems. But we are only getting started. In next video, we are going to learn the Docker commands that developers use every day. We will understand pull, images, ps, start, stop, restart, exec, logs, inspect, rm, and more. I'll show you when to use each command, common mistakes, and what Docker is actually doing behind the command. So, if you want to learn Docker properly instead of just memorizing commands, subscribe to Code with Nima because we are building this series step by step from beginner level to real world Docker development. I'll see you in next one. Thank you for watching.